Hi, I'm David Thomason, and today we're going to talk about hacking industrial control systems. In particular, we're going to be looking at those systems that would commonly be found inside of a utility substation. So what we have today here is a mock-up of some of the equipment that you would find in a substation. For example, here we have a relay. Down below we have something called an RTAC, and the relay and the RTAC are communicating together through an Ethernet switch. They're using IEC 61850 protocol, actually a subset of that protocol called Goose. And that's a layer 2 protocol that allows for the communication between these two devices through that switch. So what happens is when there's power in the substation, the RTAC down below will communicate to the relay to say that there's power, and it will be indicated with a green indicator light. When the power is turned off, the RTAC is also sending messages to the relay saying the power is off, and indicate that with a red LED indicator light. So it doesn't matter how many times we turn this light on or off, that light is going to switch only because the RTAC down below knows that there's power to the light or not. So put this into a substation format. When the power is off, there are customers and homes that don't get power, and when the light is on, everything is good. Everybody's got power, the air conditioning's working, all things are great. Now this is a very simplified presentation, but what I want to do now is I want to compare this, if you will, to the Ukrainian hack of December 2015. In this particular attack, hackers were able to gain access to the data center for a Ukrainian utility company, and at that utility company they were then able to trip the breakers on all of their substations and turn off the power for a wide region within the Ukraine. The power outage was for 80,000 customers. It affected about 230,000 people. Now, how did they get into the data center? That part we're not real sure about, but it could have been a spear phishing attack. In fact, most experts believe that it was a spear phishing attack, but it could have been a contractor that brought in malware, maybe on a thumb drive or maybe on a spreadsheet that they had given to somebody inside of the data center. It really doesn't matter, but we do know that the data center was compromised, and then the hackers were able to then go to the utilities or to the substations and trip the breakers, knocking the power out for all their customers. Now, a couple of interesting things that also happened because this was a very coordinated attack. They also had malware called KillDisk that was used to then scrub the hard drives of the SCADA systems to erase them so that any indication that they were there would not be available to them. But they also did a denial of service on the phone system, so people calling in wouldn't be able to tell the utility that the power was out. So that probably delayed their reaction to getting the power turned on. Hats off to the Ukrainians though, recognizing that their SCADA systems had been compromised. They were able to go to a manual mode and get the power restored within about 6 hours to all of their customers, and I think that's worth noting that that's a very positive thing. But what if the hackers had done things a little bit differently? Now in our substation mock-up that we have here, we have simulated that somebody has broken into the substation and installed one of these. This is a Raspberry Pi. And a Raspberry Pi costs about $50, and it's a computer that can be used to communicate on the network. We plugged it into the network using this yellow cable. It's being powered off of a USB port, but it could be powered off of anything. And as a result, it's able to gain access. And the new Raspberry Pis, by the way, have Wi-Fi and Bluetooth built into them. So for about $50, you'd be able to access the network of a substation if you got physical access to it and be able to communicate with it from possibly across the street. So now what we're going to do is we're going to simulate here that the attacker has gained access to that. We're going to corrupt the last value, if you will, of the system. That way we can turn the power off and it'll still report that everything is okay. And why is all of this possible? Well, because SCADA protocols are not secure. I guess this is a really good place for me to inject that we are not attacking any of the devices. We're not going to hack into the relay. We're not hacking into the RTAC. We're simply attacking the protocol that's being used to communicate between these systems. So, and why is that possible? Well, because the protocols aren't secure. They are susceptible to a replay attack, to an injection attack, to data corruption attacks. They don't have any encryption, there's no authentication, there's no non-repudiation, and there's really very little validation of packets that goes on between the devices inside a substation. So what I'm going to do now is I'm going to turn on the power. You'll notice that the indicator turned to green. And the RTAC is transmitting that the power is good. And now I have Sam sitting off screen, and he's going to launch an attack right now against this substation. I'll give him just a second to launch it. And as soon as he does that, I can turn the light off. And look, the power is still indicating that it's on with this green indicator. That means that the people at the data center will be thinking that the power in this substation is still turned on. Now maybe people start to call because we don't denial of service them, and the substation or the utility company says, our substation in your area shows to be working well. It must be a very local problem. Maybe not more than just your home. You need to check it out. And that could go on for some time and certainly could cause a widespread outage. And now this particular attack will continue for as long as Sam is running the attack code against the protocol. Now, this is very interesting in that we can see that that we've attacked the utility and that we've been able to compromise the SCADA protocol. But that really isn't very complicated. What really is better is that we can be able to tell you that we've indicated, or that we've been able to identify that there was this kind of an attack. So we've deployed a SpyGoose technology. It's also one of the boxes that's down here inside of the rack to monitor that network switch and to identify when somebody tries an injection attack or a data corruption attack or when they flood the network with packets. We can tell you about all those kinds of things. So as you can see here, these SpyGoose events are those particular events that we were able to identify as a course of the attack that Sam has launched on this particular network. Well, that concludes my presentation. If you have any questions, please file them down below and we'll be happy to get back to you with them, with answers. Thank you for watching our presentation.